Hey everyone, we are discussing solution of problem ABC of today's Codeforces Round 8077. So problem A is blackboard's list. Here it is given that we are having two integers which are written on the blackboard. After that the following step was carried out n minus 2 time. What is the following step? Basically the two integers are written on the board and we have to write the absolute value of their difference on the board. And since at the very start there are only two integers, but as these steps are carried out there will be more than two integers on the blackboard, so we can select any of them and we have to write the absolute difference of the selected two integers on the board again, so that the total number of written integers will be increased by 1. So that's how what this operation means actually. So now they ask that after this process was complete, obviously the list of n integers will be there, which is shuffled later on after the process, and we are given the final list and we have to recover one of the initial two numbers. Means at the very beginning of this whole thing there were only two integers, then we have to recover those two integers. Remember, since it is given that we have to write down the absolute value of the difference of the two selected integers from the operation, so obviously the numbers which we will write later on in the operation will always be positive or 0. Okay, so one thing we observed from here is if in the given shuffled n integers, if we find any of the negative integer, then it is one of our answer, and there will always be at most two negative integers in our list. And in case there are no negative integers, I mean everything is positive or 0 in our list, then the answer would be the greatest number among all the n elements. Reason being, we cannot produce it because see, absolute difference is smaller equal to the numbers contributing to it. I mean, if we are taking the absolute difference of two integers, it will always be smaller than or equal to the maximum of those two numbers. So that's why the maximum number among all the n integers can never be created using this absolute thing, or it can only be created if the other number is 0, but still we need the biggest number to create that particular number itself. So the biggest number will be one of those numbers which are present earlier before anything started. So the answer would be, let's see my code first of all. So what I did is I simply sorted the array, and then if a is 0, so after sorting, if the first element is negative, then I outputted this or printed this first element, otherwise I printed the last element. That's how I did it. Now let's come to the second problem. So minimize permutation subarray. Yeah, I kind of messed it up a bit during the contest. Sorry. So it says we are given a permutation p of size n and we want to minimize the number of subarrays of p that are permutation. And in order to do so, we can do exactly one operation. I mean, we have to do exactly one operation. It means basically we have to take two indices and we have to swap the values at those indices. So that's the operation we can do. Let's say if we have the ideal array that we wanted, then we can obviously swap the same number so that nothing change in the array. But otherwise, if we want to swap in real, then we can do that accordingly. So they have given one example, and what else they have given? Yeah, which choice of I and j will be minimize the number of. Okay, yeah, they are saying that we have to choose I and j such that this thing we have to so that the number of subarrays of p will be minimized, we have to choose such I and j. So first of all, think it that way. Let me take this whiteboard out. Okay, so let's say we are given one more thing. Let's see constants. So t is nothing. Okay, n is minimum 3. Yeah, so this is what I wanted to tell you. So since n is minimum 3, so we can see that First of all, let's see the base cases or the easy cases. Let's say if 1 is present at the first position or at the last position, then what we have to do is we just have to swap the position of the 2 to the last. If if 1 is on the first position and if 1 is on the last position, then we have to swap this value of 2 to the first position. Basically it means we will if 1 is at the first position, we'll swap the 2 with the last position, and if 1 is at the last position, then we'll swap 2 to the first position. What else we can do is, if let's say 2 is at first position, we can do the same with 1. We will swap 1 to the last position, and if 2 is at the last position, then we'll swap the position of 1 to the first position. Okay, these are the easy cases. Now let's see more trickier case, or the only remaining case which is trickier, when neither 1 and nor 2 is present at the corner, and let's say 1 and 2 are somewhere in the middle of the array. Okay, they might be other way around, that 1 is behind, after 2 or whatever. So we can see that like we have to minimize the sub array such that they form permutation. So what we can observe from here is, we can always have the whole just the whole array as a sub array, which will be permutation. And if we want, we can transform this sub array this array to such an array such that no sub array will be having a proper permutation, or simply a permutation. How we can do that? Okay, so observe that if 1 and 2 are present somewhere in the middle, then there must be the n or the greatest element either at this position, I mean this location, which is leftwards to both of these 1 and 2, or maybe in between these two, or to the right of both of these. So basically what we want to do, what we actually wanted to do for this problem is, we want to change the position of one of these 1 or 2 such that this n comes to the range of 1 and 2. For example, if n is present here, let's say in this case, then we want to put this 1 at the first position. And let's say if n is present at the somewhere over here, then we want to change the position of second to the last. And let's say if this n is present at the in between of these two, then we can change either 1 to the first position, I mean swap the position of 1 with the first position, or the position of 2 to the last position. That's all we have to do to satisfy the criteria. And why this work is, see, 1 and 2 are the only thing. Let's see. Okay, when 1 and 2 will be, one of the 1 and 2 will be swapped to one of the corner. Let's say if in this case we swap 1 to here, and from here 1 will be removed. Wait a second. From here 1 will be removed. Now n will be included in this range of 1 to 2. Then we must include all of the elements present in the array to form a permutation, because n is the biggest element and you have to have every element possible present. See, because if you will have this much of array, then also it will not form a permutation, and without one, permutation will not be there. So you have to take this much of array so that 2 will be included in the range. But again, when n is present in this range, then you have to take all the elements up till n minus 1, which is only possible when you take the whole array. That's why the only array or the sub array which is a permutation is the whole array, and that's why this works. And this is how I approached this problem. You can see my solution. So what I did is, here are the base cases which I discussed, or the easier one, and I took a map as well to check or store the position of every element. Now here I took min and maximum of both mp1 or the position of 1 and position of 2. After that, if this maximum element is between these two position of 1 and 2, then we will simply output 1 and the position of mn plus 1. Remember, I am putting mn plus 1 because here I took 0 based indexing, but we require 1 based indexing in the answer. And if this final or the maximum number is left to the minimum of either 1 and 2, then we will print 1 and mn plus 1, or we will shift mn plus 1 or the 1 which is minimum to the left. And if this maximum number is right to the max, then we will shift the maximum number to the rightmost position. That's how I did it. Okay, now let's see this problem C. And I was unable to do it in the contest, but now I am having a solution for it. So basically I think you all must have got this problem, but it is a bit trickier to implement. It is an implementation and observation based problem. So we are given n and m, and we have to fill the matrix which is n cross m matrix or the grid with number 1 through n cross m in such a way that for any two adjacent cells in the grid, the absolute difference of the values in those cells is not a prime number. So two cells in the grid are considered adjacent if they share a side. That's what adjacent means. It can be shown that under the given constraints there is always a solution. So let me tell you how I basically approached this problem. I divided two cases. Wait a minute. I divided this problem into two separate cases. When n into m is odd and when n into m is even. So these are the conditions. So what I did is, when n into m is even, first of all, in the case of even number, we can always do one thing. Let me show you this with one example. Let's say 4 cross 4. Okay, we are given nm as, or rather 4 into 5. Let's say 4 into 5. So 4 5s are 20. 20 is even. So what we can do is, we can see that here 4 is even and it is not a prime number. So 4 by 5 grid will look something like, you can always do, if let's say your row is even, then you can do 1 2 3 4 5 6 7 8 9 10 11 12 13 and so on. And you can see that this absolute difference is 1 and it is not a prime number, and this absolute difference equals to this number n, which is odd and also not a prime. And if let's say it would have been a 5 cross 4, then rather than going from this side to this side, we would have gone from this to this and then this to this similarly. So for n cross m as even value, it is simple. We can simply write 1 2 3 4 5 accordingly, as I explained. Okay, and now for n cross m with a odd value, just a minute. For n cross m as odd value, we can see that let's take one example. 5 cross 7, and 5 and 7 both are prime numbers. So for 5 and 7, it is like, and so on, 5 times. Can we copy it? I don't know. Okay, so what I basically observed over here is, we can have 1 2 3 4 5 6 7, then a row will be left. If I will fill alternating rows. 7, then 8 9 10 11 12 13 14, then one more row, then 15 16 17 18 19 20 up till 21. Okay, now when you filled this row wise and alternatively, will get up till 21. So basically how many numbers we have actually filled is n by 2 floor of n by 2 multiplied by m. Since this number, this 21 is a number which is not prime, because we are multiplying two more numbers, let them be prime or non-prime, that doesn't matter. One is m and other one is n by 2. So the next number 22, when we will put it over here, we can see that the difference between this and this will always be equal to this number. Or if we place 23 over here, the difference between this and this will again be equal to this number, and difference between this and this will always be even. So they are positioned in such a way in case of odd n cross m. So we can do 23, 24 and so on, 25, 26, 27, 28, then 29. Again you can see this and this absolute difference is even, and the difference between these two is again 21. So that's how we can approach this problem. Let me show you my code. So what I did is, if n cross m is odd, then I am simply first of all taking a number 1, and you can see the outer loop is starting from 0 and it is going I plus equal to 2, that means alternatively, and the internal loop, which is for column, is going normally, and I am doing v v I j n m plus plus, and to fill the other values with even index, or in zero indexing term the odd index, I have started from I equal to 1 and went through I plus equal to 2, I mean alternative way, and again the internal loop is simple, and did the same thing, and nm is common for both, so that the result in this loop is also updated. And for when nm is even, we simply did one thing. When n is odd, we, as I told you, I did the same thing, started I equal to 0 and up till n, the outer loop contains the row and inner loop contains the column, and simply did vvij nm plus plus. And for odd m, we did outer loop as outer loop contains columns and inner loop contains row, and did the same thing, and we printed the answer at the end. That's how I approached this problem. So I hope you got the solution of all the 3 problems, and if you like it, please like the video and subscribe to the channel. Thank you.